එක එනවා ඩයෝඩ් එක දෙපැත්තේ වෝල්ටේජ් එක 0.7 වෝල්ට්ස් කියලා එනවා 0.7 වෝල්ට්ස් කියලා එනවා. එතකොට අපි දන්නවා මේ සර්කිට් එකේ තියෙන කම්පොනන්ට්ස් තුනයි බැටරි එකයි ඩයෝඩ් එකයි රෙසිස්ටර් එකයි. එතකොට බැටරි එකෙන් 8 වෝල්ට්ස් 8ක් දෙනවා. අපි මේකට කර්චොෆ් වෝල්ටේජ් ලෝ එක දැම්මොත් වෝල්ටේජ් නියමය දැම්මොත් එහෙම ඔයාලට පේනවා වෝල්ට් 8න් මෙතන තියෙන වෝල්ට් 8න් වෝල්ට් 0.7ක් තියෙන්නේ ඩයෝඩ් එක දෙපැත්තේ. එහෙනම් ඉතුරු වෝල්ටේජ් එක තියෙන්න ඕනි රෙසිස්ටර් එක දෙපැත්තේ. ඒක තමයි අපිට VR කියලා ගත්තේ. VR කියන එක අපිට එනවා එතකොට 8 අඩු කිරීම 0.7 වෝල්ට්. ඒ කියන්නේ උත්තරේ 7.3 වෝල්ට්. හරි. එතකොට ID එක හොයන්නේ අපි කොහොමද? අපි හොයාගත්ත දැන් රෙසිස්ටර් එකේ වෝල්ටේජ් එක දන්නවා අපි රෙසිස්ටර් එකේ රෙසිස්ටන්ස් එක දන්නවා. එතකොට අපිට ID හොයන්න පුළුවන් මේ විදිහට. එතකොට රෙසිස්ටර් එකේ වෝල්ටේජ් එක අපිට එනවා 7.3 වෝල්ට් කියලා. රෙසිස්ටර් එකේ රෙසිස්ටන්ස් එක අපිට එනවා 2.2 කිලෝ ඕම් කියලා. වෝල්ටේජ් එක රෙසිස්ටර් එකෙන් බෙදුවාම මේ ඕම්ස් ලෝ එක පාවිච්චි කරලා තියෙන්නේ. අපිට එනවා ආන්සර් එක 3.32 මිලි ඇම්පියර් කියලා. පළවෙනි එකට උත්තරේ. දෙවෙනි සර්කිට් එකේ තියෙන්නේ ඩයෝඩ් එක රිවර්ස් කරලා අනිත් පැත්ත හරවලා තියෙන මේ විදිහට. ඒතර ඔයාලට පේනවා මෙයාගෙන් කරන්ට් එක ෆ්ලෝ වෙන්න බෑ. ඒ කියන්නේ මෙයා රිවර්ස් බයස් තියෙන්නේ. රිවර්ස් බයස් තියෙනකොට අපිට කෙලින්ම ගන්න පුළුවන් මෙන්න මේ ID කරන්ට් එක කෙලින්ම ගන්න පුළුවන් එයා ඇම්පියර් 0යි 0 ඇම්පියර්ස්. ID කරන්ට් එක 0යි. ID කරන්ට් එක 0යි කියලා කියන්නේ මෙන්න මේ රෙසිස්ටර් එක හරහා මම කහපාටින් මාක් කරන රෙසිස්ටර් එක හරහා වෝල්ටේජ් ඩ්‍රොප් එකක් තියෙන්න බෑ. මොකද ඕම්ස් ලෝ එක දැම්මහම මෙතන එනවා V සමානයි IR දැම්මම I බිඳුවයි කියලා කියන්නේ වෝල්ටේජ් එක බිඳුවයි. එහෙනම් මෙතන VR එක මේ අවස්ථාවේදී මෙතන බිඳුවයි වෝල්ට් එනවා. ඒතර අපිට පේනවා මෙතන බැටරි එකෙන් 8 වෝල්ට්ස් සප්ලයි එකක් තියෙනවා. රෙසිස්ටර් එක දෙපැත්තේ වෝල්ටේජ් ඩ්‍රොප් එක බිඳුවයි. එහෙනම් මෙන්න මේ 8 සප්ලයි එකෙන් දෙන 8 වෝල්ටේජ් එක සම්පූර්ණයෙන්ම තියෙන්න ඕනි ඩයෝඩ් එක දෙපැත්තේ. එහෙනම් ඩයෝඩ් එකේ වෝල්ටේජ් එක VD කියන එක මෙතන 8 වෝල්ට් කියලා එනවා. පැහැදිලිද නේද? Right. Now let's go for the second question. So we have two diodes from two types, silicon and germanium. Diodes දෙකක් තියෙනවා, silicon and germanium. ඒ වගේම resistor එකක් connect කරලා තියෙනවා series. This is series connected resistor. So this one, the first one එක, this is silicon and the second one is germanium. So in the tutorial you are given the values. So for the silicon thing, so first of all look at the orientation of the diodes. නේද? බලන්න මේකේ orientation එක බලුවහම ඔයාලට පේනවා මේක battery එකේ, by the way the battery voltage is 12 volts. battery එකේ positive එක connect වෙලා තියෙනවා silicon and germanium diode දෙකේම anode side එකට. The positive side of the battery is connected to the anodes of the both diodes. So that means these two diodes are forward biased. මේ දෙකම forward biased වෙලා තියෙනවා. So because these are forward biased, so there will be voltage drops across the diodes. මේවා forward biased නිසා මේවල විභව බැස්මක් තියෙනවා, voltage drop එකක් තියෙනවා. ඒතර silicon diodes වල voltage drop එක ඔයාලා දන්නවා 0.7 volts drop එකක් තියෙන්නේ. ඒ වගේම germanium diode එකේ voltage drop එක තියෙනවා 0.3 volts. Yes, 0.3 volts. එතකොට මේ දෙන්නගෙම total voltage drop එක එතකොට එනවා ඔයාලට දෙන්නගෙම voltage එක drop වෙනවා 1 volt. Right? So total voltage drop will be 1 volts. So it's like as the previous one, we need to find the current through the circuit and the voltage across the resistor V0. So our goal is to find V naught, voltage across the resistor, and ID, current through the circuit. So just as before, කලින් වගේමයි. So we have this cell voltage at 12 volts, cell voltage at 12 volts, and we have a voltage drop of 1 volts. So you can, when you're answering in the question paper, you have to use the KVL, Kirchhoff's voltage law. So the voltage across the resistor will be 12 volts minus 1 volt, which will be the voltage drop across the diodes. Diode වල දෙපැත්තේ තියෙන voltage drop එක cell voltage එකෙන් අඩු කරන්න ඕනේ. එතකොට අපිට answer එක එනවා resistor එක දෙපැත්තේ voltage එක 11 volt. V naught equals to 11 volt. Right? Then right, then we are given the resistance value as 5.6 kilo ohms. 5.6 kilo ohms. So we can calculate the ID using the Ohm's law formula. V over resistor के දෙපැත්තේ voltage එක, the voltage across the resistor 11 volts divided by the resistance value 5.6 kilo ohms, which will give you the answer 1.96 milliampere. So this will be your ID value for the first circuit. පළවෙනි circuit එකට ID value එක 1.96 milliampere. Right. Second circuit එක පොඩි modification එකක් කරලා තියෙනවා. There's a small change in the second circuit. The germanium diode is the both are silicon diodes now. Both are silicon diodes, but the second diode is inverse like this. So this is silicon. දෙවෙනි diode එක මාරු කරලා තියෙන පැත්ත. And the voltage drop එක මොකද මාක් කරන්න තියෙනවා මොකද මේක. So this is a change over here, right? So you can see here the first diode is forward biased. So the diode that I marked in green color, this diode, the green diode, the first diode is forward biased, but the other diode, the second diode, is now reverse biased, right? So we can, for reverse bias diodes, we can just remove this diode completely. මේක අයින් කරලා දාන්න පුළුවන්. මොකද reverse bias නිසා එකෙන් ඒක අපිට එතන open circuit එකක් විතර ගන්න පුළුවන්. ඒක හරහා voltage එකක් pass වෙන්නේ නැහැ. Right? එතකොට ඔයාලට පේනවා මෙතන මෙහෙම වුණාම, so even though this one is forward biased, there's no connection over here, so there's no current flowing in the circuit. So obviously ID will be 0 නේද? මේක forward bias වුණාට මෙතන connection එක open circuit නිසා මේක හරහා current එකක් flow වෙන්නේ නැහැ. circuit එක හරහා current එකක් flow වෙන්නේ නැහැ. ID current එක 0 amperes වෙනවා. එතකොට මෙතන diode එකේ forward bias voltage එකක්, එතකොට මේ diode එකේ forward bias voltage එකක් රැඳෙන්නේ නැහැ. මොකද current එක 0 කියලා කියන්නේ voltage එකක් 0.7 volts තියෙන්න බෑ. එතකොට මෙතන 0.7 volts තියෙන්න බෑ මෙයාට. මෙතන තියෙන voltage drop එක, මෙයාගේ current එක 0 නිසා මෙතන voltage drop එක 0 volts වෙනවා. එතකොට මේකේ extra question එකක් මේක අහලා නැහැ. ඔයාලට හොයන්න ඇතුළේ මෙතන mark කරලා තියෙනවා VD. So you need to find the VD voltage over here. VD over here. So VD will be, so you can see here, we have no voltage drop across here. So when the current is 0, because the current is 0, there is no voltage drop here, there's no voltage drop here. So all the 12 volt potential will present at this point, right? So VD will be 12 volts. right? I think you can understand that. And the V naught for this one, V naught will be 0. No current, no voltage across the resistor. Current එකක් නැහැ කියන්නේ resistor එක දෙපැත්තේ voltage එකක් නැදෙන්නේ නැහැ. Right. Right. So no questions. So remember, if you have any questions, just raise your hand. ප්‍රශ්න තියෙනවා මොකක් හරි මෙයාගේ raise hand option එක තියෙනවා කරන්න. නැත්නම් මට chat එකේ message එකක් දාන්න පුළුවන්. Right. So there's no questions. Let's move on to the next one. Okay. So there's a question. How BD? I mean, you asked for BD, right? Yeah. So VD, how did it become 12 volts? So that's a good question. I'll draw the circuit again. This one is forward biased. This one is reverse biased, like this, right? Supply is 12 volts, and there's a resistor over here, right? Right. So obviously this is forward biased. The first diode is forward biased, and the second diode is reverse biased, right? So in lectures, you have learned that if you can replace a reverse biased diode with an open circuit, right? Reverse biased diode එකක් අපිට පුළුවන් open circuit එකකින් දාන්න. Forward biased diode එකක් දාන්න පුළුවන් අපිට cell එකකින්. හැබැයි ඒක inverse side එකට තියෙන මේ වගේ cell එකකින්. 0.7 volts තියෙන cell එකකින්. මෙහෙම තමයි සමනවල දාන්නේ. But remember this 0.7 මෙන්න මේ 0.7 කියන value එක එන්නේ මෙයා හරහා current එකක් pass වෙනවා නම් විතරයි. So if you recall the diode characteristics curve, diode curve එක මතක නම් මේක තියෙන වලට මෙන්න මේ වගේ එකක් තියෙන්නේ. breakdown voltage එක තියෙනවා. And here it will be like this, right? මෙන්න මෙතන 0.7, there will be 0.7 forward biased voltage drop. එතකොට බලන්න මෙතන දැන් අපි දැනගත්ත අර circuit එකේ the previous circuit, without any doubt current is 0. කිසිම ප්‍රශ්නයක් නැහැ. current එක 0 ampere flow වෙන්නේ මේක හරහා. මොකද මෙතන මේක open circuit නිසා මෙතන, right? මේ point එක මෙතන open circuit නිසා මේක current එක flow වෙන්නේ නැහැ. current 0 current එකක් තියෙන්නේ. එතකොට අපි බලන්න ඕන diode අපේ diode curve එකේ බලන්න 0 current flow වෙන තැන 0 current එකක් flow වෙනවා නම් මොකද වෙන්නේ මෙතන? potential එක 0 volt එන්න ඕන. Right? So there's another question. To create a PD VD, I guess VD across the open points, don't we need to pass the charges through the components? If it is, won't there be a PD across the resistor? No. Right. For example, right? So for example, is there be a potential difference එකක් තියෙන්න පුළුවන්ද charges flow එකක් නැතුව? පුළුවන් නේ? දැන් ඔයාලා normally අපි මේ diode, if we forget about the diode thing, right? If you take a simple circuit like this, we have a resistor and we have an open circuit like this. If you measure the voltage across these two points, we will get the supply voltage. Make a 10 volts now. Here we will be receiving 10 volts over here. So if there's 10 volts in these 2 points, then there will be 0 volts across the resistor. That means there will be no current flowing through the circuit, right? So there could be a potential difference even though there is no charges flowing in the circuit, right? There's a common misconception. So potential difference does not require to have a charge flow, right? Yeah. Okay. Right. I think you got it right now. So the VD will be 12 volts for that. It's not asked in this question. එක අහලා නැහැ ප්‍රශ්නේ, but එක මතක තියාගන්න එතන 12 volts එන එක special case එකක්. Right. Let's go to the third question. Third question again. First circuit එක. So there's a cell with 10 volts. battery එකක් තියෙනවා 10 volts. Resistor එකක් තියෙනවා 0.33 kilo ohms. And we have two diodes. Those are similar diodes, silicon diodes. Right? Both are silicon diodes. And looking at the arrangement, you can see the both diodes are forward biased. Both diodes are forward biased. And that means the voltage. So you have to calculate the V naught, the current values of each part and V naught. So V naught across these 2 points, you can see here, diodes these two diodes are forward biased. Forward biased ලා තියෙන්නේ. එතකොට මෙන්න මෙතන V naught එකේ voltage එක එනවා ඔයාලට 0.7 volts කියලා එනවනේ. මොකද මෙතන forward bias ලා තියෙනවා කියලා කියන්නේ මේ දෙන්නම එයාලගේ forward bias voltage එක තමයි මෙතන answer එක එන්නේ. Right? එතකොට if we have 0.7 volts across these 2 points, then we have the rest of the voltage across the resistor. අනිත් ඉතුරු voltage එක තියෙන resistor එක හරහා. resistor එක හරහා voltage එකක් තියෙනවා 10 minus 0.7 9.3 volts. resistor එක හරහා තියෙන across the resistor. And using that we can calculate the current I. Just as usual, කලින් වගේමයි V over R, voltage එක 9.3 volts divided by resistor එකේ resistance එක 0.033 kilo ohms. answer එක එන්නේ approximately 28.2 milliamperes. And if you look at the circuit again, the current flowing in this resistor that 28.2 milliampere will be divided into two branches. මෙන්න මේ branches දෙකට මෙහෙම බෙදෙනවා. මේ දෙකම similar diodes නිසා මොකද වෙන්නේ? මේ දෙකේම diode එක current එක බෙදෙන්නේ equal amount වලින් තමයි බෙදෙන්නේ. equally බෙදෙනවා current එක. එතකොට එක diode එකක් හරහා අපිට එනවා. so අපිට ඊළඟට අහලා තියෙන්නේ so we need to calculate ID1 should be equal to ID2 and this should be equal to I over 2, which will be 14.1 milliampere. Both are equal. Right. The next circuit, VO ගත්ත විදිහ දැන් මෙතන පේනවා ඔයාලට මෙතන diodes දෙකක් තියෙනවා. diodes දෙකක් තියෙනවා මෙතන. diodes දෙකක් තියෙනකොට මේ diodes දෙකම මේ බැටරි එකේ සෙල් එකෙන් forward bias වෙලා තියෙන්නේ. සෙල් එකෙන් voltage එකෙන් forward bias වෙලා තියෙන්නේ. බැටරි එකේ positive එකද මේ දෙන්නගෙම anodes වලට connect වෙලා තියෙන්නේ මේ විදිහට. ඒතර මේ දෙන්නම forward bias වෙලා තියෙන්නේ. forward bias වෙලා තියෙනවා කියලා කියන්නේ මේ දෙන්නගේ voltage drop එකක් තියෙනවා මෙතන. right? අර අපි අර කලින් කරන නීතිය දැම්මොත් මෙතෙන්ට අපිට මේ forward bias diodes දෙක අයින් කරලා ඒ වෙනුවට දාන්න පුළුවන් reverse voltages දෙකක් මේ විදිහට. මේක forward bias නිසා තමයි මේක කරන්නේ. මේක 0.7 volts මෙයත් 0.7 volts. දැන් මෙහෙම බැලුවම ඔයාලට පේනවා අනිවාර්යයෙන්ම මෙන්න මේ points දෙක අතර. ඒ කියන්නේ V naught කියන value එක voltage එක එන්නේ 0.7 volts කියලා එනවා. ඒතර මේ මතක තියාගන්න තව මේ arrow head එකෙන් කියන්නේ ඔයාලගේ අහන potential එකේ direction එක. එතකොට මේකෙන් කියලා කියන්නේ මෙන්න මෙතෙන්ට respectively මෙතන potential එක voltage එක තමයි හොයන්න ඕනේ. එතකොට මෙයා 0 වුණොත් මෙයා කීයද කියලා තමයි වගේ දෙයක් තමයි අහන්නේ. එතකොට ඔයාලට පේනවා මෙතන battery එක තියෙන්නේ negative side එක පල්ලෙහාට තියෙන්නේ. positive side එක උඩට තියෙන්නේ. එතකොට 0.7 මෙතන 0.7 තියෙනවනේ මෙතන. පල්ලෙහා 0 වුණොත්. එතකොට අපේ answer එක එන්නේ +0.7 කියලා. එකත් මතක තියාගන්න. ඒක ගැටලුව හරිද? හරි. Right. Let's go to the next one. ඔව් එක ඩයෝඩ් එකක් රිවර්ස් බයස් වුණොත් අනිත් එක්කෙනා මොකද්ද කියලා අහනවා. ඒතර මෙහෙමයි. මෙහෙම එවිල්ලා අපි හිතමු එකක් රිවර්ස් බයස් අනිත් එක ෆෝවර්ඩ් බයස් කියලා. මේ විදියට. එතකොට මොකද වෙන්නේ? එතකොටත් අර විදියම තමයි දැන් බලන්න. පොසිටිව් සයිඩ් එක කනෙක්ට් වෙලා තියෙන බලන්න ඇනෝඩ් එක හොයන්න. ඇනෝඩ් එක තියෙන්නේ මෙයාගෙන මෙයා තමයි ෆෝවර්ඩ් බයස් වෙලා තියෙන්නේ. එතකොට එයාව තමයි අපිට අයින් කරලා ඒ වෙනුවට සෙල් එකක් දාන්න පුළුවන් එතෙන්. එතන සෙල් එකක් දාන්න පුළුවන්. හැබැයි ඒක රිවර්ස් සෙල් එකක් තියෙන්නේ මෙතන මේ වගේ 0.7 වෝල්ටේජ් එකක් තියෙන රිවර්ස් සෙල් එකක්. ඒක ෆෝවර්ඩ් බයස් නිසා. ෆෝවර්ඩ් බයස්. මෙයා රිවර්ස් බයස්. රිවර්ස් බයස් ඩයෝඩ් එකක් අපි රීප්ලේස් කරන්නේ ඕපන් සර්කිට් එකකින්. ඒක අයින් කරලා දාන්න සර්කිට් එක. එතකොට ඔයාලට පේනවා මේක තමයි සිම්පල් සර්කිට් එක. මෙහෙම වුණාම ඔයාලට පේනවා මෙතන වෝල්ටේජ් ඩිෆරන්ස් එක 0.7 වෝල්ට්ස් කියලා. හරි නේද? Right. The next question. So we have two diodes. Different diode arrangements තියෙන්නේ. Sorry, different diode types දෙකක් තියෙනවා. So we have two different types quartz diode, silicon one. In the right side, we have the germanium. And sorry, germanium. And we have a resistor going to ground. And we are measuring the voltage on this point. We know. Right. The main circuit supply voltage 12 volts. Both diodes are forward biased. මේ දෙකම forward biased වෙලා තියෙන්නේ. එතකොට ගැටලුවක් වෙනවා. දැන් මේක මොකද්ද වෙන්නේ? දැන් අපි දන්නවා we know that silicon has a forward voltage drop of 0.7 volts while germanium has 0.3 volts. So imagine make up your voltage එක කෙලින්ම 12 දෙන්න නැතුව. So if we incrementing the voltage slowly starting from 0 බිඳුවෙන් පටන් අරගෙන වැඩි කරනවා නම් voltage එක කවුද ඉස්සෙල්ලාම on වෙන්නේ? 0.3 තමයි ඉස්සෙල්ලාම ආව වෙන value එක බිඳුව ඉඳන් යනකොට ඒ එතකොට germanium diode එක තමයි on වෙන්නේ. මෙයා තමයි ඉස්සෙල්ලාම on වෙන්නේ. forward bias වෙන්නේ එයා. එතකොට silicon එක නා off. මොකද silicon එක නාට it requires 0.7 volts to turn on. Right? එතකොට මෙතන ගන්න පුළුවන් simple argument එක මේක. First, the germanium diode will be turning on and there will be voltage drop. එතන තියෙන voltage drop එක 0.3 volts තමයි maintain වෙන්නේ. Because it's a germanium diode. Silicon diode එකේ දෙපැත්තට උඩ තියෙන කීයද 0.3 volts තියෙන්නේ. ඒතර 0.3 volts කියන එක less than 0.7 නිසා මෙයා this is not turning on. Right? Silicon diode එක turn on වෙන්නේ නැහැ. ඒතර අපිට මෙයාව එතන open circuit එකක් විදිහට අයින් කරලා දාන්න පුළුවන්. So this is the simplified circuit. Simplified circuit එක මේක. දැන් මෙහෙම ගත්තාම වලට පේනවා resist එක දෙපැත්තේ. So we asked to calculate the ID the current values. So obviously මෙතන current එක ID1 මෙතන ID1 එක 0 amperes. එතන open circuit එකක් තියෙන නිසා. ID2 එක පාස් වෙනවා කෙලින්ම මේ resist එක හරහාත් යනවා ID2. ID2 එක කොහොමද අපි හොයන්නේ? resist එකේ value එක දීලා තියෙනවා 2.2 kilo ohms කියලා. ID2 එක so we have to find ID2 using the Ohm's law V over R, the voltage across the resistor. So this voltage, the diode, we have 0.3 volts across the diode. Diode එක දෙපැත්තේ 0.3 volts තියෙනවා. Supply එක 12 volts. ඒ කියන්නේ ඉතුරු voltage එක the remaining voltage will be present at the resistor. So we get 11.7 volts at the resistor and the resistance will be 2.2 kilo ohm. And the current value will be 5.32 milliamp. Right. Silicon germanium parallel. Silicon germanium parallel, I think this is a good example for that. Silicon germanium parallel. If it is anti-parallel, මේ දෙක දෙපැත්තට තිබ්බනම් එතකොට එක්කෙනෙක් කොහොමත් reverse bias නේ. So the one is reverse bias, the other one is forward bias, so you can find it, right? So the best method is to identify which diode is forward bias and which one is reverse bias and replace them with an open circuit or a reverse voltage. That is the best method to analyze diode circuit. Right? Okay. No questions. Let's go to the next question. Number 4. So we have another circuit with a 20-volt cell, a silicon diode, a resistor, and another silicon diode, connection like this. So both of them are silicon diodes, and just as before, you can see here, බලන්න, battery එක connect වෙලා තියෙන්නේ. So the both diodes are forward biased. Cells diodes දෙකම forward biased වෙලා තියෙන්නේ. Yeah, forward biased. This one is also forward biased. Cell voltage එක මේ පැත්තට තියෙනවා. Right? So all of them are forward biased. So we can replace the diodes with reverse voltages 0.7, because this is silicon diode, right? Here 0.7 volts, right? And oh sorry, I forgot there's another resistor over here, right? So we are asked to calculate the current I1 and D1. So yeah, I is the main current that's passing through the I is the main current that is passing through the cell, right? Yeah. So the main current passing through the cell. So how do you find that? So if you take this loop, the first loop, මේ loop එක මේ this loop එක ගත්තොත්, මෙන්න මේ loop එක ගත්තොත් එහෙම මේක තියෙනවා cells තුනක් තියෙනවා. There are 3 cells, 3 sources and 1 resistor. So you can use this loop to calculate the current across this loop, and that will be the current will be voltage divided by resistance. The voltage will be the supply voltage 20 volts minus 0.7 volts minus 0.7 volts. So there are two diode drops. Diode drops දෙකක් තියෙනවා එතන. මේක divided by the resistor value 5.6 kilo ohms. So this should give you 3.32 milliamperes. This is for I. I 3.32 milliamperes. This is 5.6 kilo. Now, so what about this branch over here? This branch. So here this current is marked as I1. So I1 passing through 3.3 kilo ohm resistor. So if you look at this loop over here, second loop, we have only one voltage source and one cell. Sorry, one resistor. So you can use that thing. So I1 should be equal to voltage divided by resistance, and there's only one cell over there, 0.7 volts, and the resistance was 3.3 kilo. This gives you approximately 0.21 milliampere of current in that branch. A part is 0.21. So here this one 0.21 milliampere this thing we have 3.32 milliamperes. So then now it is easy to calculate the current through this path. So this path is uh, ID1 ID1. So a current is coming 3.32 current is coming at here, and from that 0.21 0.2 එකක් මේ පැත්තෙන් යනවා. එහෙනම් ඊටු ටික තමයි මේ පැත්තෙන් යන්න ඕනේ. So here 3.32 minus 0.21, which gives you 3.11 milliamp. Right. Okay, so there's a question, what if there is no 5.6 kilo ohm resistor here? So if there is no 5.6 resistor, 5.6 kilo ohm resistor here, it will be a short circuit, right? Basically the diodes are short circuiting the resistor, sorry, the short circuiting the circuit. So there will be a infinite number of current passing through the loop. Make a infinite number එකක්. So if because this resistance නිසා තමයි අපිට we got the 3.32 milliampere answer. If there is no resistor over here, the resistance will be 0 here. If the resistance is 0 here, instead of this, if we apply 0 here, this will be 0. That will give you infinite amount of current. That means it is a short circuit, right? And it does not matter the other side, the other path. This path remains the same. මේක ප්‍රශ්නයක් වෙන්නේ නැහැ. අනිත් side එක remains the same because there is 0.7 volts drop එක මෙතන තියෙන නිසා මේක මේ විදිහට යනවා. මේක ප්‍රශ්නයක් වෙන්නේ නැහැ. I hope that clears that question. Okay, now we have the same circuit in the second part. We have the same circuit, but now we are introducing another diode like this. So as before, find out which diodes are the forward biased and which one are the reverse biased. ඉස්සලාම හොයාගන්න reverse forward biased මොනවද reverse biased මොනවද කියලා. දැන් ඔයාලට පේනවා, you can understand this one is forward biased, this is forward biased, and this is also forward biased. Just follow the current path. මේ current path එක ගියාම මේ පේනවා. See, මේ දෙන්නම forward biased. Starting from here again, go like this. මෙයත් forward biased. All the diodes are forward biased. Second step, replace the diodes with reverse voltages. Remove this one, remove this one, remove this one, and replace them with reverse voltages because they are forward biased. If some diode was reverse biased, we just replace them with a short open circuit. මොකක් හරි diode එකක් reverse biased තිබ්බනම් ඒක අයින් කරලා එතෙන්ට open තියන්න, ඒක open circuit, right? So all the voltages are 0.7, right? All the voltage drops across the cells are 0.7. And if you see here, now yeah, so now this side remains the same, this loop, මේ loop එක වෙනසක් වෙන්නේ නැහැ. Same as before, diodes දෙකක් reverse bias වෙලා තියෙනවා. එතකොට මෙතන voltage drop එක එනවා V equals 20 minus 1.4 volts. 1.4, we got the 1.4 from these two diodes, right? 0.7s, that means 1.4. and the resistance remains the same. So current passing through this line remains the same as previous. It is 3.32 milliampere. No change there, right? But if you look at the second loop, now we have another diode over here. So these two are opposite, inversely connected. These two cells, which I'm going to mark in yellow color, these two cells are now oppositely connected. That means the voltage of those two cells will be cancels off with each other. ඒක කැපිලා යනවා. ඒ voltage දෙක කැපිලා යනවා. එතකොට so there will be no voltage across the resistor. resistor එක දෙපැත්තේ voltage එකක් තියෙන්නේ නැහැ. මෙතන තියෙන 0.7 වලට මෙතන තියෙන 0.7 කැපෙනවා. So you can easily apply the Kirchhoff law over here, Kirchhoff's voltage law දාලා බලන්න. ඒක formula එක දැම්මම හමාරට එනවා. මෙතන resistor එක දෙපැත්තේ voltage එක 0 volts. So if this is 0 volts, then there will be no current flowing this part, 0 ampere. Current එක 0 ampere. That means this 3.32 milliampere current එක passing completely through this diode over here. So it's getting crowdy. I'm sorry for that. So this diode 3.32 milliampere. That is the D1, ID1, right? So this is ID1. This one is I, and this is I1. Right. So make sure you use proper calculations to find these things, right? You can use the Kirchhoff voltage law and current law to properly calculate this value. I'm just teaching you how to understand and dissect the problem, right? Okay. So, any questions? No, right. So we need to hurry up a bit because we have a lot of questions to discuss. Right. So the next one, the number 5, we have 2 logic circuits. So we need to find the V0 output voltage and the logic level, right? So here using the first circuit, there's 10 volts connected here, and there's another diode connected over here like this, V0 output, and there's a resistor to the ground. And you can see here, if you look at this path, it's completely grounded, right? It's starting from this 10 volts and going past this diode. That means this diode is forward biased. So this is forward biased, and this diode is obviously reverse biased. The second diode is reverse biased because the anode side එක connect කරලා තියෙන ground එකට. The minimum potential මෙතන තියෙන ground එකට. ඒතකොට මෙයා if this need to be forward biased, a negative voltage be presented here. මෙතන negative voltage එකක් තියෙන ඕනේ මෙන්න මේ diode එක. Yellow diode එක forward biased වෙන්න නම්, in order to be forward biased, at this point it should be negative value, right? So there are requests to explain the previous questions again. I will do that at the end of the lecture, right? Because I don't think we have enough time to do it. But after that, you can stay around so I can explain those questions to you, right? So just let me know which problems that you need to explain again, and I will note them down and I will discuss them after the session, right? Okay. Right. So in order to this diode to be forward biased, there should be a negative voltage at this point. We not should be negative volts. So there is no negative volts in this circuit. So that means this diode is reverse biased. This is reverse biased. So basically we can remove reverse biased diodes. We can remove them. Forward biased diodes, we can replace them with reverse cells like this. So let's assume this is a silicon diode. So 0.7 volts across here. And if you analyze the circuit, if you analyze this path, the voltage drop across this resistor will be 10 volts minus 0.7 volts. That will give you V naught value as 9.3 volts. So this will be your answer. And so the question says logic, in order to be logic level 1, consider the voltage to be 10 volts, but we can assume this voltage, this is also higher voltage, so this will be logic 1, right? Because it's a higher voltage. It shouldn't have to be 10 volts. 10 volts ma වෙන්න ඕන නැහැ. 9.3 කියලා කියන්නේ closer value එකක්. ඒ නිසා මේකේ output එක 1 වෙනවා මේ configuration එක යට. Right. For the next circuit, we have something like this. So silicon diodes, 2 silicon diodes. Here we have 0 volts. Here we have 10, and a resistor over here with the 10 volt source, and V naught over here, right? So if you follow the paths starting from any end, so here we have 10 volts. No, 10 volts තියෙනවා අපිට. So if you follow this path, මෙන්න මේ path එක follow කරොත් ඔයාලට පේනවා here we have a positive voltage, here we have a positive voltage, and here we have also the positive point, right? So there's no voltage difference across this path. මේ path එක හරහා voltage difference එකක් නැහැ, right? So that means this diode is reverse biased. ඒක open වෙන්න බෑ. But so this is reverse biased. So if you follow this path, we have positive to 10 volts over here, and the current flows in this path, and this diode becomes conductive and it's forward biased. So this is forward biased. So we can remove the reverse biased one and replace the forward biased one with a reverse voltage of 0.7 volts, right? And which will give you the voltage over here 0.7 volt, which is the answer for our question. And now this one is logic level 0. Make a logic 0 වෙන්නේ මොකද 0.7 කියලා කියන්නේ it's nearly equal to 0. ආසන්න වශයෙන් බිඳුවට සමාන නිසා ඒක logic 0 output එක low කියලා ගන්න. Right? Okay, let's go to the next question. So we have rectifier circuits, I guess. Yeah, rectifier circuits in the sixth question, number 6. So when analyzing these kind of circuits, it's best to draw the circuit in 2 different conditions, right? So first one, let's say this, in the first one we get positive cycle to the as the input එකට positive cycle එකක් එනවා නම් මේ විදිහට මෙතන එන්නේ විතර positive 20 volts එනවා නම් what happens to the diode? Obviously the diode is reverse biased. Diode is reverse biased, so that means yeah, the diode is reverse biased. That means we can remove the diode, making it an open circuit, right? So there will be open circuit over here, and the V naught value will be 0 volts, right? And for the next one, let's say we are getting negative 20 volts. Negative 20 volts up hammer. Now we can see a current path 0 to negative 20 volts. That means this becomes forward biased. So if it is forward biased, we can remove this diode, and in the first part it says yeah, second B part, if you look at the B part, it is replaced by silicon diode. So that means in the first A part, so this is A part, so we are having an ideal diode. So ideal diode, there is no voltage, there is no voltage drop, only a connection, only a short circuit, right? There's only short circuit. That means the voltage will be minus 20 volts. So what we have in our waveform will be like this. So the input voltage will be like this. It is going from plus 20 volts to minus 20 volts. And our output will be like this. Only the negative voltage will be passed, right? So this is out. The black one is in. Positive cycle එකේදී අර diode එක off වෙනවා. එතකොට output voltage එක 0. Negative cycle එකේදී diode එක on වෙලා voltage එකක් pass වෙනවා. එතකොට ඒක 20 volts කියලා අපිට එනවා. Right? Okay, the next one, the part B, says we need to replace this by a silicon diode. the only difference, this thing is same. First එක 20 volts වලදී මෙයා forward bias sorry reverse bias වෙන එක it remains the same. වෙනසක් වෙන්නේ නැහැ. But in the second one, instead of direct connection, now this is not an ideal one. Ideal එකක් නෙමෙයි. එතකොට මොකද? එතකොට මෙතෙන්ට reverse cell එකක් තමයි දාන්න ඕන 0.7. this now this is silicon diode. reverse cell එකක් දාන්න. reverse cell එකක් දැම්මම I'm sorry, this should be the other way around, right? Positive side එක මෙහෙ. So that makes this voltage less than 20 volts. So from negative 20 this becomes minus 19.3 volts. Minus 19.3 volts. And if you draw the graph again, input, and remember this the second graph will look like this. This is minus 19.3 maximum peak, and the others will be 0 like this. And if you're wondering what happens in here, these regions, so the diode will not turn on until it reach 0.7 volts, right? So minus if you draw some lines like this, it will be like this. So forgive me for the scale of the graph, right? So this should be minus 0.7 volts. Until it reach minus 0.7, it won't turn on. That means the voltage will be 0 at this point, right? After it reach minus 0.7, the input voltage reach minus 0.7, it will turn on and give you the correct graph, right? So for the next one, the number sorry, part B and part C. Yeah, we have the part C. Part C, it says what happens if we increase the voltage to 200 volts and compare the solution. Oh yeah, so I forgot another thing. So here you are asked to calculate the DC volts, VDC, for these circuits, right? So how do you find the VDC? VDC equals, for this half rectified signals, VP over pi, right? So for the first one, the part A, VDC will be minus 20 volts divided by pi, and this will be around minus 6.37 volts. And for this one, VDC will be minus 19.3 divided by pi, which will give you around minus 6.14. Minus 6.14 volts. Because this is a half a cycle, right? A half cycle in a signal එකකට තමයි 0.5 sorry divided by 5 කියන එක ගන්නෙ. Double cycles in එකකට අපි ගන්නවා 2 times that value, the VDC value. So these are all in your theory book, right? Okay, so the C part, what happens if we increase the voltage to 200 volts? Same thing. Same procedure, follow the same procedure. Now these voltages will be increased now. Instead of 6.14, it will be 63.6 for the ideal diode. If you increase the input voltage to 200 volts, for ideal diode, VDC will be 63.6 volts minus, and for the practical diode, it will be 63.38, slightly less than that. I calculate these values using VP over pi formula, right? So how we compare them? So if comparatively, if you use 200 volts, the difference between these two will be less. Percentage difference actually, right? Percentage difference will be less if you're using a higher voltage. ලොකු voltage එකක් ගත්තොත් එහෙම අපිට එන අර difference එක ideal එකේ practical එකේ එන difference එකේ percentage එක අඩුයි. පොඩි voltages වලදී percentage error එක percentage difference එක වැඩි. So that is the comparison between the circuits. Right. Okay, so we have some questions. So there's a question how to get minus 19.3, minus 19.3. So මෙතන යාලා answer එකක් දීලා තියෙනවා 20.7. minus 20.7 කොහොමත් එන්න බෑ. So you cannot get minus 20.7 because the maximum supply voltage is minus 20. Vmax is minus 20. So minus 20.7 is not possible, right? So how do you get that value? We have minus 20 volts here, diode connected over here, a resistor like this to ground. So what we do here is replace the diode by a voltage source in this way, 0.7 volts, and this point we have potential the minus 20 volts. Here the potential of this point should be increased by the cell, right? What the cell does is increase the potential from the negative side to positive side. So here we have 20 at this point, and it would be increased by 0.7 volts. This will give you minus 19. If it is the other way around, if you got it wrong, you will get like something like this, minus 0.7, which will give you 20.7 volts. Now this is not possible because the maximum voltage, supply voltage is minus 20 volts. So there's no capacitors or stuff here to clamp the voltage. So it is not possible to get a larger value like this, 20.7, negative 20.7. The range will be 20 to minus 20. So this is the range. I think that clears up. Right, let's go to the next question, the seventh one. I think now you have an idea about what to expect and how to perform these kind of calculations. So I'm So please let me know if you have any lectures today after 3. So if we need to discuss this more, can we do it after 3? Right. In this seventh question, we have input voltage of 10 volts. So let's assume the first half cycle plus 10 over here, plus 10 and 0. Uh, there will be a current path from positive side to the negative side. That will be this path, and there will be another path like this, right? So that means this diode will be reverse biased, so we can remove it from the circuit. And let's so we can remove this one also and replace it with a potential source like this, reverse 0.7 volt potential, right? And the voltage at this point, the potential at this point will be, now here we have 10 volts, and it will be 10 minus 0.7 over here. It will give you 9.3 volts at this point. And here it will be 0 volts. Here it will be 0 volts at this point. And at this point, you can see here, there's another current path. There are two identical resistors over here. So these two resistors are identical. That means this voltage, 9.3, will be divided equally at this point. So this voltage will be 9.3 divided by 2, which will give us 4. 9.3 divided by 2 will give us 4.65, around 4.65 volts, right? And what we need to find here is output waveform, right? So output waveform. So the V naught, we are getting the output across this resistor. So across this resistor, V naught will be 4.65 volts. You can see here. Here we have 9.3. Here we have 4.65. That means the voltage difference across this resistor will be 4.65. That is for the positive side, positive cycle, right? So we can draw the positive cycle. So this is the input voltage. Input is 10 to minus 10, and output will be like this. Again, remember the diode will not turn on until it reaches over 0.7 volts. That's why it is getting invert like this. So the maximum voltage will be 4.65 volts. And in the next cycle, we will get, I'm gonna quickly delete these values. And in the next cycle, we will get minus and plus like this. So minus 10 over here and 0 volts over here. So if we draw a new current path, I will draw it in a new color. So starting from 0 is going like this, going through this resistor, going through this diode, and comes around like this. And this path also traveling like this. So this is the direction of the current. And here, this diode will be open circuit. Reverse bias, that means we can replace it by an open circuit. And this diode will be forward bias. That means we can replace it with a 0.7 volts source like this. And if you look at this again, the voltage at this point will be, now we have minus 10 over here, a voltage drop of 0.7 across this diode. So that will be here, it will be minus 10 plus 0.7, which will give you 9.3 volts at here, like as before, right? Same goes for this thing, 0, it does not change. And here again, these two diodes divide the voltage equally, this potential. And this thing we have, sorry, 9.3 volts divided by 2, which equals to 4.65 volts, right? And pay attention to the direction, right? So here the green color represents the positive cycle, and the yellow color represents the negative cycle, and both cycles are in the same direction. Positive එකයි negative එකයි දෙකම තියෙන්නේ එකම direction එකට තියෙන්නේ. So that means voltage එක, V naught voltage එකත් එකම direction එකට තියෙන්න ඕනි. negative cycle එකෙත් මෙයා එකම direction එකට තියෙන්න ඕනේ. මේ direction එක change උනේ නැහැ. ඒ නිසා cycles දෙක එකම side එකට එන්න ඕනේ. Right? මේක තමයි අපේ output එක එන්නේ. So this is the output, and VDC, like as before, Vp over pi, but since we have two cycles, this should be multiplied by 2. So 2 into 4.65 divided by pi, and the DC voltage of the output will be around 2.96 volts. And the last question is how PIV, peak inverse voltage. So it's given in the theory, the peak inverse voltage will be the voltage across this resistor, the middle resistor. Peak inverse voltage, right? So the peak inverse voltage will be the voltage across this resistor, and that value is this 4.65 volts. So that will be the maximum voltage that will be handled by the diodes. Peak inverse voltage කියලා කියන්නේ මේ මැද resistor එකේ voltage එක එතන diode එකේ voltage එකට equal. Sorry, මේ diode එකේ maximum voltage එකට equal. Right. Let's go to the next question. $200 ohm resistor, and we have a Zener diode like this, and we have a 2 kilo ohm resistor here like this. Okay, so the question says we have to maintain 30 volts we have to maintain 30 volts across the output. 30 volts මෙතන තියාගන්න ඕනි. And the maximum diode current should be 25 volts. Sorry, 25 milliampere. Should be 25 milliampere. Right. So if we need to maintain 30 volts across this resistor over here, the current I that should be maintained over this portion will be V over R 30 over 2 kilo ohm, that is 15 milliamperes. So 15 milliampere should be maintained across this line throughout the circuit all the time. එතන අනිවාර්යයෙන්ම 15 milliamperes තියාගන්න ඕනේ මේ පාත් එක. එතකොට then here this current over here, let's tell this as I prime, and this current is divided into two parts like this. The maximum current of this path will be 25 milliampere, and the constant current of this path will be 15 milliampere. And the I prime should be always less than the maximum value. So the maximum value will be at the maximum point. Maximum point, 25 milliampere will be flowing from this side, and 15 milliampere will be flowing from this side. So together it at 40 milliamperes, right? So it should be less than 40 milliampere, and it should be greater than how much? Should be greater than 15 milliampere. So 15 milliampere, we have to maintain minimum current of 15 milliampere. So it should be 15 milliampere, right? So this is the range of current that should be maintained across the resistor. And the E, the supply voltage, is equal to Vz plus IR. You can use this formula using the Kirchhoff law, right? And Vz remains 30 volts, and the current, let's calculate the minimum current. Minimum current is 15 milliampere into the resistance is 200. So this gives you 33 volts. So this is the minimum value, right? And for the maximum value, instead of 15 milliampere, we have to plug in here 40 milliampere. If you plug in 40 milliampere, you get a maximum value of 38 volts. So this is the voltage range, 33 and 38. So this is the input voltage range that you have to maintain. Right, let's go to the next question, 9. Question number 9. In this circuit, we have the Zener voltage. I will not draw the circuit here. You can refer the circuit by yourself. The Zener voltage will be 12 volts, and the maximum current passing through the resistor will be 200 milliamperes. And the maximum current across the Zener diode will be also 200 milliampere. So after finding these two values, Vz and Imax, we can find the uh, power. Power equals voltage into current. So Zener voltage is 12 volts multiplied by the maximum current, which is 200 milliampere, which will give you exactly 2.4 watts of power. So this is the maximum power that the Zener diode can handle. Okay. Right. Let's move on to the next question. Number 10. So you need to find the output waveform across the RL. So in these kind of circuits, let's just analyze the circuit at half a cycle at a time. So let's say that you have a negative. Let's first take the negative cycle. So the negative will be here and the positive will be here. And if you can see here, the diode sorry, let's take the other way around. Let's take the positive cycle first and the negative cycle afterwards. If you take the positive cycle, current will flow through the diode because the diode is forward biased right now, and there will be voltage drop across the diode of 0.7 volts. If I draw the output waveform like this, input waveform in black color, and you can see the output voltage will be 0.7 volts, and at the positive cycle our output will be constrained, will be limited to that value. Okay. And in the negative cycle, like this, the diode will not be turned on because it is reverse biased, but the capacitor was charged. The capacitor was charged in the previous cycle. So what should be the voltage of the capacitor? The capacitor voltage will be, now we have 0.7 volts here. Now the make remember the input voltage is 24 volts, and from that 24 volts there was a drop across the diode 0.7 volts. That means the capacitor must have 23.3 volts across the capacitor. Now in the second half, the capacitor is now charged with this manner, like this. And because the diode is not connected right now at this moment in the second half, now we have a higher voltage at this point. So capacitor has 23.3 volts and this output has 24 volts. So we have a new voltage across the resistor, which is 23.3 from the capacitor and 24 from the power supply, which gives you the 47.3 volts negative voltage of output. So at the negative side, we should get, so I'll draw the graph again. So 0.7 positive volts and 47.3 negative volts, and this will be the output waveform. So this is called a positive clipper, positive clamper, right? Sorry, my bad, negative clamper, because this the voltage was shift to the negative side like this. The center point will be 23.3 volts. At the 0 volt potential, only the capacitor voltage will be present at the output. Capacitor voltage is negative 23.3 volts. So this is the answer for the 10th question. Let's go to number 11. Right, in the first circuit, we have something like this: a bias diode with a power source and a resistor. And let's take the first half. Plus and minus. If you have plus and minus like this, let's say this is 5 volts, right? So this one is also 5 volts. So the diode drops 0.7 volts across it. It's a drop, and the voltage across the resistor will be, so we have to add these things all together. So these 5 and 5 are adding together, and we have to subtract 0.7 by that. So that's how you get the value here. So 5 plus 5 minus 0.7, which gives you 9.3 volts. මේ දෙකම cells දෙකම supply එකයි bias cell එකයි දෙකම එකම orientation එකේ තියෙන එකම side එකට තියෙන්නේ plus minus here minus and plus ඒ දෙක add වෙනවා ඊට පස්සේ diode voltage එක අඩු වෙනවා. ඒකට තමයි මෙතන resistor එකේ voltage එක output voltage එක 9.3 කියලා එන්නේ. මේ එන්නේ positive cycle එකට. right? negative cycle එකට එනකොට මෙතන -5 වෙනවා. එතකොට මේක minus මේක plus වෙනවා. the minus plus වුණාම මෙතනත් minus plus තියෙන්නේ. So here minus plus, and these two cancels off. 5 to 5 cancel off because both of them are equal, and at the negative point the output voltage becomes 0 volt because the cell voltage and the input voltage cancels off each other. Negative side එකේදී මේක 0 volts වෙනවා. And what about the 0 volts? මේක අපි මෙතන 0 volts උනොත් මේක 0 volts වලදී 0 volts වලදී මෙතන this 5 remains there, and this 0 and this 5, this cell makes this diode forward biased, so there will be current flow through the resistor, and the voltage across the resistor will be 5 minus 0.7, which is equal to 4.3 volts. So now we have the values that we need. So we have our diagram like this. So a maximum value will be 9.3 volts, and at the 0 point we have 4.3 volts, and the minimum we have 0 volts, and the 0 is the transition point. ඒක තමයි transition point එක තමයි oscillate වෙන්නේ clamping point එක. මෙයාකට 9.3 වලින් උඩට යනවා ගිහිල්ලා 0 වලදී clamp cut off වෙනවා. Right, there's a flat point over here like this. It's a positive clamp. Right. Next circuit, we have the same circuit. Five volts, and if this is forward biased, we have 0.7 reverse voltage, and this will be our input right now. So plus 20 minus 10, right? So what happens when we have plus 20 here? Plus 20, this will be plus, this will be minus, and the voltage will be adding together. 20 plus 5, 25, and 0.7 will be subtracted. අඩු කරන්න ඕනේ ඒක. එතකොට මෙතන voltage එක එනවා 20 plus 5 minus I'll do it here. Positive එකදී 20 plus 5 minus 0.7. This value will be 24.3. 24.3, right? And the negative cycle, negative 10, this is minus, this is plus, and now because this minus 10 is greater than 5, minus 10 is greater than 5, that means this diode will be reverse biased now. It will be turned off, right? So if this is turned off, there will be no current flow in the circuit. That means the voltage across the resistor will be 0. So it's simply, it will be 0. So this will be your output circuit, output waveform, right? So maximum value 23 at 24.3, and the minimum value will be 0 volts. Right. Let's go to the next question. So we have a resistor like this, a diode, and a cell like this. So we are getting the output across here, we not, right? I'll draw the input waveform like this. Plus 16 to minus 16. Right. So first of all, let's analyze the positive cycle. If we get plus 16, what will happen? And now obviously this voltage over here is this is 4 volts, right? So if there is a voltage drop, it will be 7.7 volts, right? And since this voltage, the 16 is greater than 4, what will happen here? So let's start from the beginning, shall we? Yeah. So let's say this is 0 volts. Okay, so if it is 0 volts at this point, in this point, this point is 0 volts. If it is 0 volts, this diode is forward biased now, using this voltage 4 volts, and the voltage across the system, these two things, the V naught will be 3.3 volts. So at at the beginning, the voltage will be 3.3 volts. It will be like this, right? So this will remain 3.3 until this reach 0. The output reaches 0. Sorry, input reaches 0.7 volts. Sorry, not 0.7. Until the output reach 3.3 volts. So after 3.3 volt, this voltage get increased. That means this diode will be turned off, reverse biased. The diode will be reverse biased. That means the diode will be open circuit here. And after 3.3 volt, that means it will follow the input line like this until it reach 16 and again comes to 3.3 volts. And when it goes below 3.3 volts, the diode will conduct and the voltage will remain at 3.3 volts. So this will be your output form. So this is a special kind of circuit because now we are taking the output from this section, So this section has a constant voltage if it is active. So that's why we get this kind of constant voltage. And when it's turned off, that's the only point that it can conduct or produce more voltage, right? So that's it for those circuits. Now let's go for the question number 12. I think we could be able to finish this up in time. Right. Question number 12. We have another clamping circuit like this. So the input waveform is like this: 10 volts, minus 10 volts, 0. Okay, just as before, let's analyze the first analyze the positive cycle. At the positive cycle, the diode will be conducting like this, and the capacitor will charge. Positive side is positive, negative side is negative, and the charge voltage will be 10 minus 0.7 volts, which is 9.3 volts. The capacitor will be charged to 9.3 volts in the positive cycle. And the voltage across the diode will be 0.7 volts. That is the voltage at this point, at the positive cycle, 0.7. And in the negative cycle, the diode will be reverse biased. The diode will be disconnected because it's reverse biased. Yes, it will be reverse biased, and the supply voltage is minus 10 volts, and these two voltages will be added together to perform the next one. So minus 10 minus 10 minus 9.3. So look at the orientation here: minus, plus, and minus. So that means this voltage and this voltage should be added together to produce here. So that will be 19.3 volts present at here. So it will go to minus 19.3 like this. So this will be your output. And let's go for the next question. Right. So it will be like this, and this is our input voltage, input form, something like this. Plus 10 and minus 20, 0. Right. So here we have 5 volts here. Right. Okay. So let's analyze the positive half first. Um, yeah. First, let's analyze the negative half here first. Negative, positive. So this is negative 20 volts now. So negative 20 volts. As you can see here, this part is now conducting and the diode is turned on. And the output voltage here will be the voltage across this line. This point over here will be 5, and there will be a voltage drop in here 0.7. That means the voltage on this point will be 4.3 volts. So at the negative cycle, we will have a voltage of plus 4.3 volts. So see here, this is the negative cycle. Negative cycle, we will have a voltage of plus 4.3 volts. And the diode will be charged now, right? So this is negative and positive. The diode will be charged to a voltage of, so we have a 4.3 drop over here. This side we have 4.3. We are inputting 20 volts here. That means diode will have the rest of the voltage, which means 20 minus 4.3 volts, which will be 20 minus 4.3 volts, 15.7 volts. 15.7 volts. And in the next cycle, the positive cycle, this becomes positive, this becomes negative, and the voltage is plus 10 now. And you can see here we have plus and minus here, and the diode is now reverse biased because we have a higher positive voltage over here. Now diode have a reverse bias voltage, and now the output at this point will be the addition of the input voltage plus 10 and the capacitor charge voltage, that is 15.7. So both of them together give us around not around yet, exactly 35.7. So the positive half will be like this, and the voltage will be 35.7 volts. So this will be your output waveform. We go like this and like this. So it's a positive clamper. Right, so that's it for the clamper circuits. Now we have the final question. Isn't it 25.7? Let's look at it. Oh, sorry, I made a mistake over here. So here, the capacitor voltage in the negative cycle, the capacitor voltage will be 20, not minus 24.3. It will be plus 4.3. It should be plus 4.3. So that gives you, it will be 24.3 over here. 24.3. The capacitor voltage will be 24.3. And in the positive cycle, we get 10 volt from the supply, and the capacitor already has charged to 24.3. And look at the symbols, right? So it is not subtracting, we have to add them. We have to add the voltage. So 24.3 plus 20, sorry, 24.3 plus 10 gives us 34.3. So the positive voltage here will be not 35 something, it will be 34.3. It's not 25.7. So I don't know how you came up with that answer. 25.7. Oh yeah, I got it now. Yeah, you must have add 25 and point 0.7, right? So point 0.7 cannot be added over here. If it is forward biased, point 0.7 should be subtracted, right? The point 0.7 should be subtracted. Let me see it again. Yeah, so let's do it again. We have a capacitor, we have the diode, we have the cell like this, and let's take the negative cycle first to be easy, right? Negative. So that means this one is negative, this is positive, and now this side becomes 0 volts and this side becomes negative 20 volts. So that's what it means, right? And if this is 0 volts, this point over here becomes 5 volts. This is plus 5 volts because the voltage difference of this volt, this is 5, right? So and here it becomes, so this is a diode, right? So diode has a voltage drop across it, so it should be reduced. So this here we have 4.3 volt potential, and the voltage difference across the diode, across the capacitor will be, now we here we have plus 4.3 and here we have minus 20 point, not minus 20, right? So the difference will be 24.3. So pay attention to the sign. Yeah, we have a negative sign over here and we have positive sign over here. So the difference will be 24.3, right? So that is the capacitor voltage. And in the next cycle, we'll get minus, so is it minus 10? Um, no, it's plus 10. So yeah, we will get plus 10 volts. And now the capacitor will be charged in form of this. So I will draw it like this. So negative side here and positive side here like this, right? So in the next circuit, there will be a positive volts like this, and the capacitor is charged like this to 24.3 volts. This is the orientation. Now you can see the diode is not in play here because it is reverse biased. We can remove it, right? Diode is not there. So the total voltage of this point, of this thing will be the addition of these two. That is 34.3 volts, and this is a positive value, right? I think that clears it up, right? The diode always drops the voltage in this direction, right? So it's dropped the voltage 0.7. Always the anode has the higher voltage and the cathode has the lower voltage. So remember that. So if you find the anode voltage, it will be greater than 0.7 than the cathode voltage, right? Let's go to the final question. I think our time is up, but let's just take another 10 more minutes. Right. So these are called voltage doubler circuits, right? So to analyze these things, we have to follow the same rule as before, right? So let's draw the circuit again. It will be like this, okay? And so let's analyze the cycles now. So let's say if you are getting a negative, sorry, let's say if you are getting a negative voltage, right? So when it's getting a negative voltage, so here negative, positive, that means this path is active, this diode is active, and this diode is deactivated. So we can remove this diode and we can replace this diode by a voltage source, a reverse voltage source of 0.7. Now the capacitor voltage will be, let's take our voltage as V in, Vi, and I'm sure that you are in your theory, you have taken ideal diodes for this one, so there's no voltage drop. So I will take account the ideal diode. I will take account the diode voltage drop here. So if you take this kind, if you have this kind of problems in your exam, so you can answer them, right? So there will be diode drops here now, 0.7 volts. So the voltage of the capacitor Vc will be Vi minus 0.7, right? And the orientation, the charging polarity of the diode will be minus and plus, like this, right? So now I will remove these markings right now. So after the first cycle, it will be like this. The diode is now charged to a voltage V in minus 0.7, right? And in the positive cycle, if we have positive and negative over here, if you remember, the diodes were like this, and here. Now this is the second cycle, and if you look at this thing, now the current flow path is in this way. Now this is off. That means it is reverse bias, so we can remove it like this. And because this is forward bias, we can remove that diode, and instead of that we can replace it by a voltage source of 0.7 volts, right? Now we have V in over here, and see the signs minus plus. So those two are opposite. That means these voltages, the V1 and this voltage should be added together, and the 0.7 will be subtracted. That's how you get the voltage across this capacitor. So this capacitor V1 plus the capacitor voltage Vi minus 0.7, and we have to subtract this the diode drop over here 0.7. So this gives you uh, basically 2 Vi minus 1.4. So in your lecture, you took the diodes as ideal, so there will be no why diode drops here, that means this value should be 0. Now you get the your usual answer 2 times the input voltage. So this is why this is called a voltage doubler, right? So if you are using practical diodes, the answer should be like this: 2Vi minus 1.4, 2 diode drops. And the last question is a bit different than the previous one. So we have a diode like this, a capacitor here, capacitor here, a diode like here, this, and this will be our input source now. And the voltage, we are getting the voltage out from these two lines. This is the output. Right, as usual, we will analyze the circuit. So let's take this positive half first. Let's take the positive voltage. We take the positive voltage. You can see this path is energized. This path is energized. That means this diode is reverse biased. So we can remove this diode. And instead of this diode, we can place a voltage source, 0.7 volts, right? And this capacitor will be now charged, and the charged polarity will be like this, plus and minus. And the charge voltage, the capacitor voltage, will be the input voltage Vi minus 0.7 volts, capacitor voltage, right? Now let's analyze the negative cycle. So I'll redraw the diodes again. And in the negative cycle, here will be negative and the bottom one will be positive. And if you follow the path, you can see now this is the correct path, and this diode will be forward biased and this will be reverse biased. The upper diode will be reverse biased. So we can remove the upper diode, make it an open circuit, and we can remove the lower diode and replace that diode by a voltage source, an inverse voltage source like this, with a voltage drop of 0.7 volts, a practical diode. And now, if you look at the capacitor here, now the positive side is connected to this side of the capacitor, and the negative is connected to this side. And the voltage of the capacitor will be the same thing, the input voltage Vi minus the voltage drop from the capacitor, 0.7 volts, and it will give you this value. And if you look at here, the signs of the capacitors, minus, plus, plus, minus, that means these two are perfectly connected in series, right? So that means these two are like two batteries over here connected. So the voltage across these 2 points, this V naught, will be let's say this is VC1 and this is VC2. So the voltage across these two lines will be VC1 plus VC2. That will give you the final answer, 2 times Vi minus 1.4 volts. So same as before. If you consider this this diode as ideal diodes, this 1.4 becomes 0. There will be no voltage drop across the diodes, and you will get the usual 2 times input voltage. That means the voltage doubler circuit. Right. So that's it for the tutorial. I think I've covered all the parts, and you understood most of the tutorial. And so I'm prepared to answer any questions that you have if you have time. Um yeah. So anyone who has any problems that regarding the tutorial that I already discussed, you can ask me through the message, the chat section. So we have a question. If we take two diodes, germanium is less power loss. Even though why? Oh yeah. So why using a higher voltage drop diode instead of a lower voltage drop diode? So actually, this thing. I'm not sure about the exact answer, but I think there is a difference between the generation and the cost of the diode. So germanium, uh, the ideal diodes are actually better than the practical diodes. So the goal is to reduce the reverse voltage, sorry, the forward bias voltage as much as possible. So in that terms, germanium diodes are better than silicon diodes, but my guess would be it will be more cost effective to use a silicon diode than the germanium diode. That's why they are still in use in our industry. So in a nutshell, the better one is to use the lower forward bias voltage diode. So that means the germanium diodes. Germanium diodes are better than silicon diodes. Recording එක LMS දානවත්ද? So I have the video file with me. මං ගාව තියෙනවා video එක. I will මම මේක දෙනවා sir and because I don't have the access to the LMS. So sir ඔයාලට කියයි. මං හිතන්නේ mail එකක් දාලා කියයි මේක අවශ්‍ය කට්ටියට මේ වුණොත් ඉල්ල ගන්න පුළුවන්. Otherwise I can ask from him and I can send it to you your emails, but I think the best way to do is contacting Buddhika sir, so he will tell you what to do. I will give the video file to him and you can take the file from him. um, right, so the tutorial is concluded right now. So if you have any questions, you can ask me. So if you are satisfied with the tutorial, now you can leave the session. Question 5, part 2. Oh yeah, so question 5 part 2, I will do it again. So again, if you are finished, you are free to leave, right? Okay. Right, so question 5 part 2. um so it was like this, the resistor, a cell and a ground source. This was 10 volts, and here we had plus 10, and here 0 over here. Right. So our V naught point was this, right? So this thing just follow the circuits, right? So let's consider the first diode. පළවෙනි diode එක බලන්න. පළවෙනි diode එක බැලුවාම in order to this diode to be forward biased අනිවාර්යයෙන්ම මෙන්න මෙතන voltage එක should be greater than 10. මේ පැත්ත මෙන්න මේ එයාගේ anode side එක අනිවාර්යයෙන්ම should be greater than 10. equal උනට වැඩක් නැහැ. So we have the potential 10 10 මෙතන තියෙනවා 10 එක. We have 10 over here. It does not matter. It should be greater than 10, not equal to 10, right? So here the potential should be greater than 10, and you can see here there is no way this point has a potential greater than 10. So that means the upper diode is reverse biased. So we can just remove the diode, make it open circuit. And let's take the lower diode. Lower diode, we have plus potential over here, zero potential over here. Now we can clearly see there's a current path like this. මේ පැත්තට තියෙනවා current path එක pass වෙන්න පුළුවන් පල්ලෙහා cell එකකින්. එතකොට මෙයා forward bias වෙන්න පුළුවන්. පල්ලෙහා කියන forward bias වෙනවා. ඒක forward bias කියලා කියන අපිට ඒව remove කරලා ඒ වෙනුවට අපිට දාන්න පුළුවන්. We can add a voltage source of 0.7 volts reverse bias, right? දැන් බලන්න potential අපි mark කරොත් එහෙම in the green color I will mark the potential. Here the potential will be 0, here the potential will be also 0. This point potential will be 10, it will be plus 10 due to the battery cell, right? And this point the potential will be 0.7 plus because of this diode. Yeah, forward bias, එයාගේ කටා current එකක් pass වෙනවා. There's a current flowing through the diode, and this side is 0. That means there, in order to be a 0.7 volt difference, this point potential will be 0.7. So V naught will be equal to 0.7 volts. That's why it becomes logic 0. Understand? Is it okay? Right. What else? Yeah. I think that's it. So no more questions that I can see in the chat. Right. Okay. Right. I hope that you have gained some knowledge during this session. So you will be given the next tutorial regarding the transistors and FETs and the logic gates in the near future, maybe in the next week or so. And Buddhika sir will be giving you more information regarding that, and we will be doing some tutorial classes after this one also. Right. So thank you for joining in. See you in the next tutorial. Right. Goodbye, everyone.